Hey there and welcome! Ever get that feeling your data's hiding something from you? Well, today, we're putting on our detective hats. We're going on a hunt for what are called statistical outliers. These are the sneaky little data points that can mess up your entire analysis, totally twisting the story your numbers are trying to tell. Ready? Let's get into it. So here's our game plan for today. First, we'll figure out what exactly we're looking for. What is this hidden distorter? Then, we'll learn how to actually spot them with our own eyes. And finally, we'll break out the big guns, a couple of simple but really powerful mathematical methods to confirm their identity. So let me just ask you this right off the bat. Can you really trust your data? Is it telling you the whole truth? Because sometimes, just one single point, one little imposter hiding in the numbers can change the entire narrative. The real trick is just knowing how to look. All right, first things first. We need to get to know our culprit. So, what exactly is an outlier? And maybe even more importantly, why should we care? In simple terms, an outlier is just a data point that's the odd one out. It doesn't really fit in. I like to think of it as an imposter in a police lineup, right? You've got all the similar-looking points clustered together, and then there's this one character way off to the side that's either way bigger or way smaller than everyone else. And if you're wondering if one point can really make that big a difference, just look at this. It's pretty wild. On the left, you've got a super simple set of numbers. 1, 2, 3, 4, 5. The average, it's 3. Makes total sense. Now look at the right. We just change one number. The 5 becomes 100. And bam, the average shoots up from 3 all the way to 22. That is a huge distortion, and it shows you exactly why finding these imposters is so important. Okay, so we know outliers can be a really big problem, but the real question is, how do we find them? Well, it's time to open up our visual toolkit and see what we've got. When it comes to just spotting these things visually, we've got 3 main weapons in our arsenal: scatter plots, box plots, and histograms. Each one gives us a pretty unique way to look at the data and helps us pick out those imposters. So first up, we have the scatter plot. See how most of the dots are kind of hanging out together in a big group? They're following a trend. But then you've got these other points, way out on their own, totally isolated from the main crowd. Those are our outliers. They're the ones breaking the pattern. Next up is the box plot, and honestly, this chart is practically built to find outliers. All the normal data is packed right inside that main box, and the lines coming off of it, which we call whiskers. Anything that falls outside of that, it gets marked as its own little dot. It's like the plot is literally pointing and saying, hey, look at this one over here. And our third tool is the histogram. Now, data isn't always nice and perfectly symmetrical. Sometimes it piles up on one side and creates this long, stretched-out tail on the other. We call that a skewed distribution. And where do you think our outliers are hiding? Yep, all the way at the very end of that long tail, far away from where all the main action is. So looking at charts is a great start. It gives us some really good clues. But to be sure, to get some definitive proof, we need to bring in a little bit of math. Don't worry, it's not scary. Our first method is called the IQR method. And really, it's all about drawing some clear lines in the sand for our data. Now, interquartile range sounds super technical, I know, but the concept is actually really simple. All it is the middle 50% of your data. Just imagine lining up all your numbers from smallest to biggest. The IQR is just that chunk right in the middle. It's basically the box part of the box plot we just saw. It's where all the normal, typical data likes to live. So how do we actually use this? Well, once we know the size of that middle chunk, the IQR, we can use it to build what I like to call fences around our data. We calculate a lower fence and an upper fence. And the rule is dead simple. Anything that jumps over those fences, either below the bottom one or above the top one, is officially an outlier. No guesswork needed. It's a clear, simple rule. All right, on to our second big mathematical tool, the z-score method. Now, if the IQR method was all about building a fence, the z-score is a bit different. This one is more like taking out a measuring tape for every single data point to see just how far away it is from the group's center.
Okay, don't let the formula on the screen freak you out. The idea behind it is actually really straightforward. All we're doing is taking a data point, figuring out how far it is from the average, and then measuring that distance in standard deviations. And a standard deviation is just a fancy term for the typical or standard amount that data points usually spread out from the average. The final number, the z-score, tells you exactly how many of these standard steps away from the center your point really is.
And this all leads us to the magic number. And that number is 3. You see, in most data sets, almost everything, and I'm talking like over 99% of all your data, is going to fall within 3 standard deviations of the average. So if you calculate a z-score for a point and it's more than 3 or less than -3, that point is a long way from home. It's so unusual, so rare, that we can pretty confidently call it an outlier. So the process is really just a simple recipe. You find the average and the standard deviation for your whole data set. Then, one by one, you calculate the z-score for every single data point. Anything with a score above 3 or below -3 gets a red flag. And there you have it, a really solid mathematical way to find those imposters and clean up your data. So you see, it doesn't really matter if you're using your eyes with a scatter plot or using math with the z-score. The point is, these techniques take you from just kind of guessing to actually knowing. When you clean up your data this way, you can be way more confident that the story it's telling you is the real story, the accurate one.
Okay, so we've got all these awesome tools to hunt down and get rid of outliers. But I want to leave you with one last really important question. Just because you can remove an outlier, does that mean you always should? Because think about it, sometimes that weird data point isn't an error. Sometimes it's the most important piece of information you have. It could be a scientific breakthrough, a major security breach, or that one result that changes everything. The real skill, the real art, isn't just in finding them. It's in knowing when to listen to what they have to say.